Ever wondered about the building blocks that make up the programs you use every day? Well, it's time to unravel the mystery of structured programming, the paradigm that makes it all possible. At its core, structured programming is a way of writing programs using clear, logical structures, executed step by step. Imagine a set of instructions, ordered and finite, that solves a problem. That's an algorithm. The simplest control structure is a sequence, statements executed one after another. But it's not all just sequences. There are two other control structures. Selection, where actions are chosen based on conditions using if or switch, and repetition, where actions are repeated using loops. Output. Now let's travel back in time to 1972. That's when Dennis Ritchie and Brian Kernighan created the C programming language. Known for its speed, portability, and low-level nature, C was a game changer. Fast forward to 1980, and we have Bjarne Stroustrup introducing C++, an extension of C that added object-oriented, generic, and abstract data type support, all the while preserving efficiency. Every C++ program you encounter will have a main function, the starting point of execution. These programs often include libraries, use the standard namespace, execute statements inside the main function, and return a value at the end. C++ language, much like any other, is made up of letters, digits, symbols, and whitespace characters. Comments are the translators, explaining the code but ignored by the compiler. Keywords are the VIPs, reserved words with predefined meanings that can't masquerade as identifiers. Identifiers, on the other hand, are the names for variables and have to follow a strict code of conduct, like starting with a letter, containing no spaces, and being case-sensitive. Output. Values in C++ are measurable quantities. Constants are the unchangeables, values that hold their ground during program execution. Variables are the changemakers, named memory locations whose values can switch up. Every variable has a name, type, value, and size. Data types are the rule makers. They define how data is stored in memory, the range of values, and allowed operations. You have your basic data types like int, float, double, char, bool, and void. Variables have to be declared before they're used. This declaration specifies the type and name and may include initialization. Assignment uses the on operator and replaces previous values stored in a variable. Output. Input and output in C++ are done using standard streams. Output gets the help of count and the insertion operator namomine, while input relies on sin and the extraction operator hats. Multiple values can be read or printed in one go. Arithmetic operators are the calculators. They include addition, subtraction, multiplication, division, and modulo. Operator precedence sets the order of operations. Parentheses first, then multiplication, division, modulo, followed by addition, subtraction. Compound assignments such as plus bias, ties, kais, bisus, and percentage provide shorter forms of common operations. They combine the assignment operator with arithmetic operators. Increment and decrement operators are the adjusters, modifying a variable by 1. The prefix versions change the value before it's used, while the postfix versions use the value first and then modify it. Constants, declared using the const keyword, must be initialized at declaration, and their value can't be changed during program execution. Output. In summary, structured programming involves sequential execution, proper variable declaration, understanding data types, operator precedence, and the difference between integer versus floating point division, and prefix and postfix increment. So next time you use a program, Remember the logical structures and steps that make it all possible.